come to Dennis Teophilo Mangasila laws. The first law is known as Dennis principle. It states that the brain capacity of the dead organism is the same as that of the fetus, embryo, and a newborn baby of age ranging from 0 to 2.5 years, provided that all of them have no capabilities of thinking and remembering. The second law is known as Dennis heavens and earth surface joining theory. It states that when the whole world is planted with the trees with the large roots, this may result in the raising of the land until it join the heaven. Hence, no space left, provided that all buildings are removed. Dennis laws of laws. The estimated position of an object in a law of a constant in number is given as the ratio of the position of that object in law to the constant number of objects in the law. It is calculated as follows. The estimated object loss is equal to the position number of the object over constant number of objects in one law. Note, this law cannot be applied for the position number equal to 0 or 1. Application of this law of laws. First, determining of the passenger seat law, determination of the student position in examination room, determination of the position of a bottle in a crate. Note, the law can be demonstrated mathematical, and we shall see example in the next session. Now let's see the examples. Let's see one single example over here. Example on the Dennis law of laws. The first one. A Saibaba agent provided a passenger a ticket with a seat number 35. Find the law in which a passenger will sit, and each law had 4 seats that are given. We have given seat number 35. The number of seats in one law is 4. Required the law at which the passenger will sit. Then from the formula, passenger law is equal to passenger seat over number of seats in one law. Then it will be 35 divided by 4. Then we get 8.75. Then it is approximately to 9. Hence the passenger will sit in the 9th law of the seat. Let us prove below. Let's say, each law it has 4 seats. Now if we count 35, it is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth law. Then after counting, I've seen that the 35th seat it is on the 9th law. Okay, we are going another law, which it is known as Dennis constant formula. This formula I have already displayed firstly, as it is stated as follows. First, the Dennis charging constant formula was made to find the length of the charging bar with respect to the percentage. Dennis introduced a constant value which he called Dennis constant dk, which is equal to 0.042 centimeter per percentage, and they come up with the formula as it is shown below. Charging bar length in centimeter is equal to Dennis constant times charging percent. As we know, the value of Dennis constant is 0.0 centimeter per percentage. Then let's see an example. And the iPhone 12 Pro was charged to 8% by using a Olamio fast charger. Calculate the length of the charging bar length given the value of Dennis constant is equal to 0.42 centimeter per percentage. Solution, we are given charging percent, which is 8, dk constant is 0.042, required charging balance. See the sketch below. This is the charging balance whereby we know that when we are charging, this bar are moving toward the light side. So when it let's say maybe when it was charged to 80%, the lens, it was here. After removing the charger, this bar was ending here. Now we need to know or to find the length of this bar from here to this point over here. Now by using that formula, we have given the percentages. Then we know the decay constant, density constant is equal to 0.042. Then if we times this here, we get 3.26 centimeter. This is it will be the value of the length of this charging bar length, and this can be measured by using a ruler. So when you measure a charging bar length of the phone, which it has been charged to 80%, it will give you the length of 3.26 centimeter. Okay, now there is a new machine which it has been discovered by Dennis on the last work, which it is known as wizard chopping machine. Wizard chopping machine is an equipment designed for chopping or cutting vegetable so that can be easily cooked. It was made so that to help the majority to chop their vegetable within a short time, especially when there is a large number of people and vegetables are needed, especially in funeral meetings, at school, and even at large hotels and restaurants. The working mechanism, or how it works, with the chopping machine. In order to understand that, in order to understand what I'm going to explain, observe the diagram below and of the sum of the machine system. Now let's say this one is the motor with is the motor. This is the motor. This is the motor. This is the motor. Small motor. Small motor with a bearing over here, and this is a bearing, and this is a bearing with the belt, which it is joining the first bearing and second bearing. So when it is switched off, when it is turned on, this motor, this will cause the first bearing to rotate, and since the first motor is connected to the second bearing by using a belt, it will cause it to rotate. Also, this is a large motor with the bearing. Also, this is a bearing. This, it is a knife. So this is also this bearing and the second bearing are joined by using belt, rotating belt or chain. So when it is turned on, it will rotate around this way. So when it is rotate, it will make also the knife rotate fastly. So then here, what is the function of this belt over here? This belt should be made in such a way that inward side should have rough surface, and should be wide of about 25 centimeters, so that we can place here vegetable on top of it, and also should be covered on top so that we can place over here the vegetables. Then as it is rotate, when motor it is rotate, it will cause the vegetable move toward light side, toward the knife, rotating knife, and we are putting the knife on the side where there is a large motor, in order to make it rotate at high speed. So when it rotates, it will meet with the vegetable, then it will chop them into smaller pieces and easily cooked by a cook, as it is shown below. So it is shown how movement look alike. So when you turn on this motor, it will rotate in this way, and when it rotates this way, it will cause the first bearing to rotate this way, and also this way it will rotate this way. And here at the top we will place the vegetables. These vegetables will move toward right side. And when you turn on this large motor, it will cause this bearing and this bearing to rotate like this way. And since the knife is fixed towards the second bearing, and also it will rotate with a fast speed, since this motor is too large, so even its power to rotate, it will be high. And this system is made to be parallel, and the distance from here, from the knife to the bearing, or where the belt end, should be of about 2 centimeters or 0.5 centimeters, so that to enable the whole vegetable to be cut or to be chopped into small pieces. Yeah, these are all about the explanation which I have made. So also, we are using, you can be asked why we are using the large motor. We are using the large motor in order, we are using the large motor compared to the to this on the side on the knife, because this large motor, it will enable us to make the knife rotated at a greater speed as compared to the smaller motor, which it will rotate on the small speed as compared to this, so that the vegetable which are coming here will come with the slowest speed, but it will meet the knife which is rotating at the fast speed, so as to be chopped to the small pieces. Yeah, I hope you have understood me. Yeah, this is all about Dennis or wizard chopping machine, which it has been discovered. For more points, for any challenge, then you can comment. Thank you.